Welcome to the second lecture dealing with the unit circle. We're going to actually this time fill in the entire unit circle. The first time around we asked you just to fill in radians and degrees plus the four main axis points. This time we'll actually fill in the exact values as well. So what we want to do is to start by doing degrees and radians, and I'm going to go through quickly those again. We know 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then finally 360. And I'm going to walk you through the process that I take filling out the unit circle, and you're going to create kind of your own method going through, but I'm going to at least show you kind of how my brain processes it, and maybe it'll catch on for you as well. Then I jump to the 45, and I do 45 degrees intervals, 45, 90, 135, 180, 225, 270, 315, and then 360. And then I count by 30s. 30 degrees and 60 degrees, 90 degrees, 120, 150, 180, 210, 240, 270, 300, 330, and finally 360. And you'll notice based on what we did in the lecture the other day too, I'm counting the same way I counted when I do radians as well. So degrees should be the easiest. The second thing, because it's a unit circle, I'm going to do the four axis points. So this is the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And that's the second thing I tend to put in my unit circle. The third thing I'm going to do, and I'm going to change my color here, the third thing I'm going to do is the radians. So I'm going to start with 0 radians, and I'm going to count the same way I did. 90 degrees is the same thing as pi over 2. 180 degrees is pi. 270 is 3 pi over 2. And 360 degrees is 2 pi. And then I'm going to start counting my pi over 4s. Which is the 45 degrees. So pi over 4 is 45, 2 pi over 4 reduces, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which reduces, 7 pi over 4, and then 8 pi over 4, which again reduces. Okay? Those are the ones I don't tend to write my little notes in the middle because those ones are pretty nice and easy. It's the other ones that I tend to write in. The second thing we learned the other day was 30 degrees, which is pi over 6. And then 2 pi over 6 would reduce to pi over 3. And 3 pi over 6 would end up being pi over 2. So this is 4 pi over 6. Which reduces to 2 pi over 3. That 150 would then be 5 pi over 6, and that doesn't reduce. 6 pi over 6 is just pi. 7 pi over 6 is at 210. 8 pi over 6 is at 240, but that reduces to 4 pi over 3. 9 pi over 6 is the same thing as 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. And finally, 11 pi over 6, which doesn't need to reduce, 12 pi over 6 is 2 pi. And again, the more you practice this, the better you will get at this. And so this is what we did just the other day. And again, this is what we feel by the second lesson should be no problem to do. I'm going to change my color, and we're going to do the exact trig values. Now, some of your Algebra 2 teachers might have taught this in triangles. I do everything off the unit circle because this is the only resource you get for Chapter 4 because a lot of this stuff isn't calculator based. So here's what I do. We want you to remember basically 3 points, 3 coordinate points, or 6 trig values, and really we only want you to know the 30, the 45s, and the 60. Because our way is, if I use the unit circle to get my way around, I shouldn't have to memorize those. So I remember a pattern. and I start at the 30 degrees. 3, 2, 1, and now I go backwards. 3, 2, 1. And this pattern of 3, 2, 1, 3, 2, 1 is what I use actually to remember the unit circle. Now the exact trig values are the square root of 3 over 2, the square root of 2 over 2, and 1/2. And my guess is those are pretty familiar to you. So the other way going down, the square root of 3 over 2, the square root of 2 over 2, and 1/2. And now you have the 6 trig values. Now the bigger question is, what the heck does that mean? Well, okay, here's the main idea. If I give you a coordinate point, x, y, which is on the circle, it corresponds to the point, the cosine of my angle, the sine of my angle. That didn't work very well. The cosine of my angle and the sine of my angle. So what that means, as I look at what I just did, is that the cosine of 30 degrees is the square root of 3 over 2. And the sine of 30 degrees is 1/2. And if you can remember the pattern 3, 2, 1, 3, 2, 1, what I can show you is I can reflect my way around the circle and find the rest of the exact trig values. Now, in the first quadrant, we know our points go positive x, positive y. In the second quadrant, negative x, positive y. In the third quadrant, negative x and negative y. And in the fourth quadrant, positive x, negative y. And so I'm going to take that idea and I'm basically going to just move around the circle. So I take this first top point, and what I'm going to do is I'm going to kind of draw this line across till I get to the top point over here. The only thing that changes between this point to here is that instead of the x value being positive, we said in the second quadrant it's negative. So my point is negative 1/2 square root of 3 over 2. And I take this second point and I basically trace it across. And again, the x changes to a negative square root of 2 over 2. The y value stays a positive square root of 2 over 2. I go again, trace this one across, and I get a negative square root of 3 over 2 and a positive 1/2. What that means is if I took the cosine of 3 pi over 4, I would answer that the cosine, because it's the first value, is the negative square root of 2 over 2. Okay, so I'm going to do the reflections again. I'm going to start with this first point and go down. So in this case, instead of only the x being negative, both x and y are negative. Negative square root of 3 over 2, negative 1/2. And I take my second point and drop it down. Negative square root of 2 over 2, negative square root of 2 over 2. And I take this third point and I drop it down. Negative 1/2, negative square root of 3 over 2. Same idea, you can take this and move this point around to the fourth quadrant, or you could take the first quadrant and drop it down. Either way, the only thing that changes in this case is the y is negative. So square root of 3 over 2, negative 1/2. Square root of 2 over 2, negative square root of 2 over 2. And 1/2 negative square root of 3 over 2. And again, we only asked you to remember a pattern, 3, 2, 1, 3, 2, 1, and we can get ourselves around the rest of the circle. And I'm going to tell you one more time, why do we do this? Because eventually I'm going to say to you, what is the cosine of 5 pi over 4 without your calculator? So I go to my unit circle. 5 pi over 4 is the same thing as 225 degrees. Cosine is the x value, so my exact answer is the negative square root of 2 over 2. I'm going to put it down here because you can't see it very well. Okay, this is the idea of what's coming up, and we're going to ask you to do it fairly quickly and without the use of your calculator. So as I look at this, we want to look at the fact that in the first quadrant, cosine is positive and so is sine. In the second quadrant, cosine is negative, but sine is positive. In the third quadrant, cosine and sine are both negative. And in the fourth quadrant, the cosine is positive, but the sine is negative. And those are things you want to keep in mind. Now another thing that you need to know, and I just stick actually right on my unit circle, and you've got some room at the top, this is an important thing. The tangent of an angle is sine of an angle divided by cosine of an angle. This is something you'll need to know, and we'll actually get more in depth in it tomorrow, but your Algebra 2 teacher would have said memorize 9 trig values, the 3 sines and cosines, and the 3 tangents. And I'm telling you, I don't want you to memorize anything but a pattern, 3, 2, 1, 3, 2, 1, and I can help you find a tangent by taking sine divided by cosine. And we'll practice that more. But this is the idea going through. So thank you. Questions on unit circle, again, please stop and let us know.